gradually we got so used to this energy abundance and availability whenever we wanted to have, we gradually became energy blind. We have taken energy so much for granted. We have taken the availability of water for granted. We have taken temperate climate for granted. And none of those are constant. And all of those are now in tipping change mode. If you give yourself the luxury to think what is important when it is not yet urgent, the final outcome or policy or solution you can develop is far superior than when in panic. The reason why I still work and will continue to work as long as I have energy is to actually explain to people about that, so that we do not get into a mode where we develop policy out of desperation, because that will not be civilized and that will not be peaceful.
Energy and materials are at the heart of our complex relations with China. We entered the era of post-peak materials, as we discussed previously. This conversation is about the energy blindness that policymakers need to overcome.
For today's talk, we're very pleased to have Hans van der Loo, the chairman of the Institute of Integrated Economic Research in Switzerland, and former vice president concerning Brussels and European Union at Shell. As a systemic thinker currently concerned with climate change, having spent at least 15 years advocating and advising on climate change at, among others, the World's Business Council for Sustainable Development and the European Union, in terms of setting the scene. I recently read that Jim Skea, the chairman of the IPCC, noted in June this year in his keynote of the update of the 7th assessment cycle, that under the current business as is scenario, current peak warming above pre-industrial levels will be some 3 degrees above that level. And in their worst case scenario, we will have temperatures above 1.5 degrees centigrade, starting in 2030 already and lasting until the deep 2080s. It is clear from the IPCC end that there is a concern. And yet, just a few days ago, during the United Nations General Assembly, we heard a certain head of state declare that, and I quote, "Climate change is the greatest con job ever perpetrated on the world," in his opinion. Now, clearly, Jim and this head of state are not on the same page. What the UN states on the causes and effects of climate change is that fossil fuels, coal, oil, and gas are by far the largest contributor to global climate change, accounting for some 75% of global greenhouse gas emissions and nearly 90% of all carbon dioxide emissions. Fossil fuels are used for many things, ranging from medicine to gasoline to power our cars. But by far, for more than 60%, fossil fuels are used to generate energy. Clearly, there is a link between the fossil fuels, the energy system, and the climate system already. And for me, having worked at Shell in the past, it reminds me of when I attended Ben van Beurden's farewell speech, former Shell CEO. And he was challenged by employees on what his greatest challenge was as an energy company CEO to combat climate change, to which his answer was to explain today's energy system to policymakers. Now, if we hark back to the 2 examples of Jim Skea of the IPCC and the head of state, it is clear that there seems to be a certain form of blindness going on, perhaps willing, perhaps not, as to the relation between energy and climate change. And perhaps this blindness even extends further. In today's talk, building on the work of, among others, Nate Hagens, we'll dig into this question of climate blindness, energy blindness, and explore what other blindnesses we might have that stand in relation to it. Without further ado, I'd like to hand the floor to Hans van der Loo to share his keynote speech with us. Thank you very much, Hans.
Thank you, Simon. I understand that there's quite a number of people online, also in other parts of the world. And I think that none of you this morning have thought about how nice it is that gravity is exactly like last week. Because if gravity would have been 40 times higher, your muscles would not have been sufficiently strong to get yourselves out of bed and behind the desk you're sitting on now. Equally, none of you thought this morning how nice that the share of oxygen in the air is about 21% and not 30%, because if it would be 30%, the small spark would ignite any cotton in the room. Now, it's not important that you think about those things, because the share of oxygen in the air and the gravity on this planet will probably remain the same for thousands, if not millions of years to go. However, there are a few other things that we have not thought about either consciously that are equally important, but may change even in the course of our lives. And so I'd like to start with the first slide. Last month, Johan Rockström, who is the chief scientist of the Potsdam Climate Institute, who has been measuring these boundaries, he said that the seventh boundary of the seventh planetary system that are essential for humanity to thrive has been crossed. So the latest one that they measured was ocean acidification. It's perhaps small. It's the one that is about at 4 o'clock. So you can see it's now reaching the edge of the green circle and moving out there. Ocean acidification is the consequence of two factors. One, as Simon already said, the use of fossil fuel, of course, is the very reason why we have so much anthropogenic carbon dioxide emissions. So it's both, and 70% of the carbon emissions have been absorbed by the oceans, because that is also about 70% of the world's surface. Equally, the climate warming, a lot of that has been, again, about 70% has been absorbed by the oceans. So the combination of warming and more acidified oceans has meant bleaching of coral reefs, migration of species in the sea, and basically also the extinction of a number of species that cannot support that. But now let's get back to this, the topic of today, the blindness on energy. So here you can see what normal people, including all of us, think about as individuals. What we find important is happiness and health for ourselves, for our families and those we love, which is completely normal. Those that have perhaps leadership roles in society, be it in business or in politics, have to be concerned with societal parameters, such as how is the economy doing, how is the culture doing, how are the values that we cherish in society doing. But that again is only possible when there are ecosystems in which we can have the luxury to consider those considerations. So we need species and ecosystems as well. But even species and ecosystems cannot exist unless there are materials and energy. So you probably all are familiar with the Maslow triangle at an individual level. This is the Maslow triangle at a societal level. And materials and energy are the very foundation of it. Now, why do we talk about reality blindness, which is actually, we think, a term that we coined, but I learn all the time. I was in Brussels earlier this week, and there I learned a new term, complexity blindness. Reality blindness is actually the result of having gone blind on the energy side. Let's think back how the energy supply of society was before 1800. And 1800 is only 200 years ago. And we've been around for about 200,000 years. So throughout that 200,000 year period, humans have always lived on renewable energy. Some of it stored in the form of biofuel, because a tree takes time to grow. So that's a little bit of stock. But for the rest, wind and solar are energy flows. It's there when it's there. It's not there when it's not there. So when did the miller mill the grain? Well, when the wind was blowing. And when the wind was not blowing, what did the miller do? Well, he's planting tulips or painting a boat, but not milling. And the same for the Dutch trade ships in the East India Trading Company. You all may have heard the name trade winds. The Dutch did not stay so long in Indonesia because it took a long time to load all the cargo. No, they could not get back because the rigging of the ships with sails that are not with one end to the mast, but halfway around the mast, they needed winds either from behind or diagonally behind. They could not sail with winds that were other than that, and hence they could only sail when the wind was open, the wind opportunity was open to go from north to south and from south to north. So our society was determined by energy supply. That determined what happened in society. With the discovery of both coal as a fuel and the steam engine by James Watt, there was a sea change in human society, namely that we no longer had an energy supply-based economy, but an energy demand-based economy. I'm an entrepreneur. I come in the office at 7 o'clock in the morning. I switch the button on, and the economy runs on energy until 5 o'clock when I switch it off. So it's the demand side that determines economic activity, and no longer the supply side that determines economic activity. Many people do not realize how material switch this was. Just like you did not think this morning about gravity or about the share of oxygen, gradually we got so used to this energy abundance and availability whenever we wanted to have, we gradually became energy blind. And now we are thinking that it's our creativity, our imagination, our innovation that actually drive economic wealth and GDP. Well, of course, it's like the recipe of a famous cook. This morning when I met with Ivo and with Simon, I told about the example of visiting Paul Bocuse, the greatest cook ever. He died a couple of years ago, who had a restaurant called Le Coq d'Or in Lyon. Now just imagine we go there. And he says, you can all pick whatever you like and you can eat the whole menu. So one of us takes with truffe and the other something else special. And then he says, would you like to visit the kitchen? Well, of course, this is like the Olympus of haute cuisine. So we all go to the kitchen, and there Paul Bocuse is, together with his junior cooks. And the first thing that strikes us, it's cold in the kitchen. I'm sure that you never ever visit a cold kitchen, because the kitchen is always warm because of the ovens and because of the fire. And so we asked Paul, why is the kitchen cold? That is because we have no energy. We have no gas and no electricity for the pots and the pans to go. So then we think, well, perhaps we get sushi. But then we look around on the counters and we see no ingredients either. So there are no ingredients in the kitchen and no energy in the kitchen. So we're a little bit surprised and go back to the restaurant and sit down. And Paul comes to the table and says, I told you, you could eat the whole menu. Well, we could indeed eat the menu paper that it was printed on, but nothing else. So this is the idea behind it, that we have taken energy to be so normal that we no longer think about it. And we've become to believe that our recipes, our imagination and innovation is the base of our wealth, but they're only recipes to make things and services with materials and energy. Take that away, all our creativity and innovation will produce nothing. They are basically algorithms or recipes to make things from energy and materials. Here you can see what this last 200 years look like, and it is absolutely staggering. In 1800, the world consumed some 5,000 terawatt hours, forget about that, it's a unit of energy, 5,000 terawatt hours of energy metabolism. Today, that is close to 200,000 terawatt hours. So what's important to remember, we now consume 40 times more energy than we did 200 years ago. In the meantime, of course, population increased eightfold from 1 billion in 1840 to 8 billion now. And actually, what is interesting, that the population growth grew with the energy availability, because that enabled warmth, so we didn't die from cold. We could actually irrigate our land with warm pumps. We could make fertilizer, which is also made from oil. And so in 1840, for the first time in 200,000 years, we arrived at 1 billion. In 1930, we were 2 billion. So we had doubled in just 90 years. The third billion was added in just 30 years, in 1960, when I also joined the party. And so in my life, it has tripled again from 3 billion to nearly 9 billion. So if the world consumption grew 40-fold and the population 8-fold, that means that energy consumption per capita grew 5-fold. But that's only an average, because what we also know is that half of all the CO2 emissions are attributable to just 10% of the world population, and that is us. And this is just one example of what I call a non-linear or really exponential development. There is another one, and that's this board. You Simon said that we cannot read the index on the graphs. I said, that's correct, and it's by purpose. I do not want you to look at each individual graph. I invite you to look at the pattern in each graph. And each graph shows an exponential pattern. And if this would be the dashboard of spaceship Earth, and you would be the astronaut guiding it, you would say, Houston, we've got a problem. And indeed we do. Now, if I take a helicopter perspective on our energy consumption, as I already said, we have been using for 200,000 years energy flows. And in 1840, we started to use energy stocks, prehistoric energy stocks. As you can see here, past solar, that is why it is fossil, because it's from the past, is 500 million years of condensed prehistoric photosynthesis. 500 million years was the total. We now know through the Hubbard curve that half of all the energy has been consumed. I won't bore you with numbers, but half is 250 million years of stock buildup. And we did that in the last 200 years. So that means that if you consume 250 million years, in 250 years, that means we have consumed 1 million year of past solar production per calendar year. In 2018, we had a nice round number. We consumed 4.5 million years of stored prehistoric production, because that 1 million years is, of course, the average over the last 200 years. So right now we are at a consumption rate that per year we consume what nature needed 22 times the period that humans were on this planet. So 200,000 years times 22, that's the 4.5 million years. So our energy metabolism is just époustouflante, as the French say. And we're now approaching this little red star, so we're nearly at the peak of the carbon pulse, and now we have to go down on the other side. Now, it's not that there's nothing at that question mark, because there are hopeful promises like thorium and, of course, efficiency, but we will have to address sufficiency as well. Of course, the flip side of all this energy metabolism is that we've been emitting a lot of CO2. And of course, we've known this already since the late 19th century, when Arvus Svante Arrhenius established that CO2 is a greenhouse gas, not the strongest one. Methane is much stronger, but taken as this sort of the marker for global warming. And since the 1960s, we've been measuring this and having meetings about this problem. And every time we've got the Hansen testimony or the UN framework on climate change, UNFCCC, of course, which was the result of the 92 Rio Earth Summit. Then we had the Kyoto Protocol, we had the Copenhagen Accord, and in 2015 we had the Paris Agreement. But there was a lot of talking, but also a lot of failing to act. We think we got a solution with renewable energy. And indeed, sun and wind are free. But our lights in our offices do not run on photons, but on electrons. So we need to capture the sun, then we need to convert it, then we need to store it, because the sun is shining during the day and we have the lights on during the evening, unless you are in a room as we are now, which has no windows, then you go blind during the day as well. But so to capture sun, we need metals to capture, to convert, to store, and to distribute it. And they are not free. And on the left-hand graph, you can see in blue the production of copper over the last couple of decades. And you see that varies a little bit, but is relatively stable in output. But the red lines is the consumption of energy in order to find the copper. And the crux, and this is the most mathematical that I will go, I promise. At the beginning of last century, the average quality of copper ore that was mined in the world was 2%. Now, 2% is a quality indicator because it means that you have to excavate 50 tons of ore to get 1 ton of copper. That's the 2%. And of course, we are always lazy and efficient, so we always go for the low-hanging apples first. So we have harvested all the low-hanging apples, and right now we are mining the higher-hanging apples, and the average density of copper ore we mine today is only 0.5%. And yet at the same time, at the lower right-hand graph, you can see the copper consumption. So not only is the amount of copper increasing, the amount of energy per ton of copper is increasing as well. So we basically have a double whammy of the resource Wende challenge. The Germans talked about the Energiewende. We now have a challenge of the Resourcewende. And it is not availability, but accessibility. And it's not the physical presence of copper, but the energy remoteness to get that copper. I have to do ever more effort to get there. And then, of course, there's another dimension that if you look at China, since it's the China Cosmolab, it is a very big country and it is extremely well endowed with many critical minerals, many critical materials, notably neodymium. Now, you may not know or have heard of what neodymium is. It's a kind of magnetic metal that you want to have, because if you can have an X turn in neodymium, you get more electricity and revert. So there's 2 tons of neodymium in every wind turbine that you see on the North Sea. And of course, in every electric car, there's neodymium as well. And if it's neodymium, then you need less electricity to get the torque of the engine. So I just explained the physical reality squeeze, namely the decreasing density of the raw materials, the ores. And China has not only has a lot of natural resources under its own territory. When Europe kind of started to neglect Africa, they actually moved in. Just like in nature does not allow any vacuum, geopolitics does not allow a vacuum either. And when the West retreats, the Chinese moved in. Europe is a very particular continent, very dear to all of us. We're all Europeans, all Dutch, I presume. Well, not all, we have foreigners working for us as well. But Europe is special in 6 dimensions. We are still the biggest single market. I say still because our growth rate is lower than that of certain other countries, so these economies will bypass even the European market. We're also the smallest continent. Here you see Europe projected inside Australia. And if the top of Norway and perhaps Sicily does not quite fit, there's enough place left and right to accommodate all of Europe. But in Australia, there's only 21 million people. And in Europe, if we include the Brits, we're 500 million. So we are the smallest continent. We're also the most densely populated continent, and with the exception of Japan, also the most aging continent. But what's also important, we are the fastest warming populated continent. Antarctica is a continent even bigger than Australia, and it is warming faster than Europe, but of course nobody lives there. And we are the most resource poor country, which of course is a function of the size. And as a result, we are the most trade dependent continent, because our wealth comes from importing materials from outside the European Union, inside the European, adding value, making Mercedes, Bordeaux red wines and Armani suits and exporting them to the rest of the world. So this is a very difficult predicament. So no other nation or no other area has more interest in stable circumstances than Europe. And of course, geopolitically, we are now in a very rocky area. One other dimension I just want to mention is that peace is very much the result of a balance between what is more expensive, defense or attack. When attack is more expensive than defense, we have longer periods of peace. Now we've entered an era where defense is more expensive than attack. You can now, with a 20,000 euro drone, fly into Europe, and we need to launch a 3 million Patriot missile to get it down. The Manhattan scientists that developed the first atomic bomb kept the doomsday clock, which is the clock that measures the time that we are left from war. Of course, it varies. In times of peace, it runs back. In times of tension, it runs up. It now stands at 90 seconds before midnight as a result of this imbalance between the cost to attack and the cost to defend. Finally, I would like to say a few words about a particular effect of global warming, namely that if the warming goes faster, then it means that also the ice will melt faster. And if the ice at the Antarctic and at Greenland melts faster, that translates into sea level rise. And this is completely normal and ongoing, because there are 3 cycles that we're all dependent on, and only 2 of those you are aware of. The first one is that the Earth rotates around itself 24 hours, and that gives us day and night. The Earth rotates around the sun, our central star, and that gives us the seasons and the years. And if you know how old you are, that is the number of times that you actually traveled around the sun. But there is another dimension that we never complete, and that is the Milankovitch cycle, which is actually the rotation of the X, or the angle of the X around which the Earth rotates, and it goes 13,000 years down, 13,000 years up. And when it is in the most upright position, we have ice ages, and when it's in the most diagonal position, we have no ice ages. And we are now in a movement from an upright position towards a diagonal position, irrespective of what we do. And so ice has been melting naturally anyway. And so, for example, just 8,000 years ago, on the left side map, you can see this is what Northwest Europe looked like. So actually, the Netherlands had no ports. Great Britain had no ports. Even Ireland had no ports because it was all one big landmass. And people lived in a land that no longer exists. It was called Doggerland. But in the past 8,000 years, the oceans have already risen by more than 60 meters. And Doggerland is now Dogger Bank, it's the shallowest part of the North Sea, where we built all these wind farm parks. And the average height of the North Sea is indeed the 50, 60 meters of sea level rise that we've had so far. If all the ice of Antarctica would melt, that will add another 70 meters of sea level rise. And these two pictures are made by a Dutch company called Van Oort. They have actually mapped 42,000 kilometers of vulnerable coasts in the world, of course, with their ideas how they could protect them. Of course, if your coast is very long, then it will cost more to protect than when it is very short, like in the Netherlands or Belgium. And of course, what's also important is how many people are exposed to sea level rise. And here you can see the Ganges and Brahmaputra deltas, or indeed the Mekong River Delta, and also Shanghai is a very exposed area. So let me conclude by actually making a comparison that Simon suggested me to take this morning. And he said, why don't you refer to COVID? Because I started my talk with saying that we've got two phenomena that are characteristic for our time. One is the inertia of big systems. And when they start tilting and reach a tipping point, then we are in danger, which we are. And the other one is the non-linearity or exponentiality. Now we know exponential curves from the COVID days, and we knew the healthcare system had to stay within capacity. So the number of people in need of intensive care beds had to be less than the number of IC beds available. And of course, if there was a shortage, you could put a container with extra IC beds from China, or you could rent hospital wings in Germany. But of course, we cannot rent more capacity for Earth systems. So what you see on the left is we have to stay within capacity of the healthcare system. But today, business as usual, we are way running out in terms of climate risk to the capacity of Earth to maintain conditions that are conducive for humans to thrive. It's maybe of interest to this audience that the term Anthropocene, which means area made by man, but not era suited for man, was invented or coined by Paul Crutzen, the 5 years ago deceased chemistry Nobel Prize winner. But we are children of the Holocene. Holocene conditions, framework conditions, is what we need to thrive. If we really will fully go to Anthropocene conditions, we will not thrive in that. So if I perhaps can include why the title was Reality Blindness, it is for the reasons I explained. We have taken energy so much for granted. We have taken the availability of water for granted. We have taken temperate climate for granted. And none of those are constant. And all of those are now in tipping change mode. And the four problems that I see in society, and what keeps me busy more than 8 hours a day, is that we do not see reality. And here I just cited, for you some more nice words in there. I worked 30 years for Shell, and greenwashing companies do exist. I think some others do more of it than others, but it happens. Greenwashing is denying reality and presenting things nicer than they are. But equally, NGOs are also reality blind, and they are committing themselves a lot to green wishing. Mr. van der Loo, we have to stop with oil Monday. So, that's interesting. Well, if we stop with oil or fossil on Monday, we'll have civil war the next weekend. We do not want that either. And then, of course, you got the politicians who are power addicted, who sometimes do understand what we explain, although many don't, but that's my job to explain. And when they explain, they say, Mr. van der Loo, what a great idea. Why don't you come back in 2 years' time when we've had the elections, then we can talk again? Because if I start talking about this now, it actually may threaten my re-election. And of course, I sometimes have the privilege to either meet the minister or have a meeting in the office of the minister, and I often ask the counterparts, your colleagues worldwide, do you think your minister knows what the word means on his door? And they say, well, it means minister. Yes, but what is that? Well, it's the head of the ministry. No, minister means servant. Like administer a drug, you serve a drug to somebody. So if you think that minister means serving your re-election, then that is a wrong comprehension of what that word really means. I now work a lot with scientists, and a lot of the things that I talk about, including climate cooling, which is not the topic of this conference, but happy to come back to speak about that. That's Simon and Ivo. But many of the insights date back from the 1980s. That is nearly half a century ago. And even though I worked a lot on this topic, many of the things 5 years ago I did not know. Perhaps I was also reality blind. The problem that most of us have is that we always have importancy competing with urgency. And the way we are genetically programmed is that we always prefer or prioritize urgency, because when you see a lion chasing at you, you should not, oh, I'll just stay here and I think I'm going to solve building the roof of my hut. No, you have to run immediately, because otherwise you will not build your hut at all. So we tend to prioritize urgency over importancy. And you probably all know this 2x2 matrix, you know, high, low for importancy, high, low for urgency. So what's not urgent and not important, just delete, don't do that. What is important and urgent, do right now. The problem is in the two boxes. Something that's important but not urgent, and something that's urgent but not important. And the full inbuilt box is in that area, and it eats away our time at the expense of doing what is important but not urgent. Because if you ignore what is important but not urgent long enough, it actually moves one box and it goes into the box of now it's urgent and important. But then when it's there, you've got less degrees of freedom against the back, with your back against the wall, you can do much less. So if you give yourself the luxury to think what is important when it is not yet urgent, the final outcome or policy or solution you can develop is far superior than when in panic. The reason why I still work and will continue to work as long as I have energy is to actually explain people about that, so that we do not get into a mode where we develop policy out of desperation, because that will not be civilized and that will not be peaceful.
I think this is it for today. I also invite you to again look at our website www.chinaknowledgenetwork.nl, where you can, for example, also find on economic thinking and how energy is lacking in that picture, some more interesting and thought-provoking talks that help shape the maybe not urgent yet, but very important to consider agenda that we all have here at Foreign Affairs. Thank you for your time and have a lovely day.